This is a Riemann surface. Riemann surfaces are two-dimensional manifolds together with an additional complex structure. An n-dimensional manifold is a Hausdorff topological space X such that every point P in X has an open neighborhood which is homeomorphic to an open subset of Rn, an n-dimensional Euclidean space. That is, a continuous bijective map, or a mapping with a continuous inverse. Let's give some preliminary definitions. If X is a two-dimensional manifold, a complex chart on X is a homeomorphism phi from U onto V of an open subset U in X onto an open subset V in the complex plane. Then two complex charts, phi 1 and phi 2, are said to be holomorphically compatible if the map phi sub 1 inverse composed of phi sub 2 is 1-to-1 and holomorphic. We define an atlas on X to be a system U of charts from U sub I to V sub I for every I which are holomorphically compatible and which cover X. A complex structure in a two-dimensional manifold X is an equivalence class of analytically equivalent atlases. That is an identification of elements, which means that every chart in the atlas is holomorphically compatible with each other. Finally, we define a Riemann surface as a pair X and sigma, where X is a connected two-dimensional manifold and sigma is a complex structure on X. Locally, a Riemann surface X is an open set in the complex plane. In fact, the complex plane is a non-compact Riemann surface. The complex projective line, or the Riemann sphere, is a Riemann surface that possesses an intrinsic symmetry. If we define the complex projective line by adjoining the complex plane and the ideal point at infinity, then the topology of the complex projective line is simple. It's merely the open subsets of the complex plane together with the sets V union infinity, where V is the complement of a compact subset of C. The complex torus is considered a Riemann surface of genus 1. That is, it has one hole or one handle. Then a Riemann surface of genus N is in some sense n tori glued together. We define the lattice gamma by the set of all linear combinations of the linearly independent generating vectors omega 1 and omega 2 with integer coefficients spanning the lattice. Two numbers z and z prime are called equivalent mod gamma if z minus z prime is in the lattice. The set of all equivalence classes is written as C mod gamma, which can be thought of as a compact Hausdorff topological space, the torus, which is the Cartesian product of unit circles. The Gaussian curvature of a Riemann surface, which is the measure of intrinsic curvature of the surface, can classify it uniquely by the uniformization theorem as being either elliptic with k equals 1, parabolic with k equals 0, or hyperbolic with k equals -1. The curvature can be calculated by the Gauss-Bonnet theorem by computing certain integrals where chi of m is the Euler characteristic of the surface, equal to 2 minus 2g, where g is the genus of the surface.